One of the common problems in software development is allowing access to user data in a secure way. Over a decade ago, there were several ways of doing this, from giving your username and password away to third-party services to numerous proprietary authorization services that each company implemented. Imagine a scenario like this. You, the user, wants to use an application like Spotify. Spotify uses friends lists to build its social music aspect, so why not get that data from an existing social network? To log into Spotify, you need to provide access to your Facebook account. And prior to 2006, one way of doing this was to ask the user to enter their Facebook login info, their username and password, to grant access to that data directly. Now, of course, this approach is full of security holes. You have no way of knowing whether Spotify is handling your data in a secure manner, and on top of that, using it in the way that they specified. If they aren't, and they get hacked, now your Facebook information is compromised. With the advent of social networks and all the rich data that came along with it, many apps wanted to connect to these services, but there wasn't an ideal way of doing so. Handing over your username and password is obviously risky, so the big companies didn't do it this way. But instead, they had their own proprietary set of authentication and authorization methods. Proprietary solutions mean that widespread adoption wasn't easy. Back in 2006, in an attempt to solve this problem, the OAuth working group was formed. OAuth, short for Open Authorization, is an authorization protocol and not one used for authentication. There are a lot of buzzwords here, so let's break down the jargon. Authentication is the process of determining the identity of a user. Is this user who they say they are? In contrast, authorization is the process of determining what the user can do. What permissions do they have? OAuth, being an authorization protocol, isn't concerned with identifying a user. Instead, it deals with the authorization of a third-party application to access user data without exposing the user's credentials. Now, before we go on, it's important to realize that OAuth is not a framework or a tool that you use. Like protocols in Swift, the OAuth protocol specifies an open standard by which a service should implement authorization. Now, there are many moving parts, so let's break it down. Now, I should also note that I'm going to go over the OAuth 2 specification. OAuth 1 is still in use today, but we're only going to touch on the latest spec. Let's set up an example. Let's say that we're building an application that shows a user's treehouse data in a resume format that they can share with employers. This application pulls data about popular courses that the student has completed, keywords indicating the topics they're comfortable with, and so on. To make this work, we need access to a student's data. In this scenario, we have 3 players: the application, the user, and the Treehouse API. We want the user to grant the application access to their data via the Treehouse API. When the user arrives at our application page, there is a Login with Treehouse button. The user clicks this button, and the application then sends an authorization request to the Treehouse server. In return, the Treehouse server displays a window asking the user to grant access to the data required. You should be familiar with this process. Going back to our Spotify example, or really any other service nowadays, it's common to encounter a Login with Facebook button where we provide access to some of our Facebook information. If the user grants access here, the Treehouse server then sends back an authorization grant to our application along with an authorization code. We use this authorization code to send another request on behalf of the user to the Treehouse server, this time asking for an access token. This access token is a very specific piece of information that is tied to the user and the protected data that they granted access for. Our application asks the user to grant access to badge unlock information on the Treehouse server. This means that using our access token, we only have access to that information and not, say, the user's address. We can now use this token as part of our requests to the Treehouse server for information. When the Treehouse server gets a request, it ensures that the access token is valid and has not expired, and that the data being requested by our application has been granted access by the user. Once all this is verified, the Treehouse server then sends the protected resources back to our application. There are a couple important things to note here. First, at no point was our application involved in authentication. When the user clicks the Login with Treehouse button, if the user is already logged into Treehouse in that particular browser, then there's no need for authentication and we proceed directly to authorization. If, however, the user is not logged in, they log in the window that pops up. But our application is not involved in that process. The Treehouse server handles that all on its own. So this is not part of the OAuth flow. How the user is authenticated is completely up to the service being used. Now, in the case of Treehouse, they would log in with their username and password. In most cases, there are separate authentication, authorization, and resource servers. When we authorize our app, we use an endpoint that directs us to the authorization server. None of the user's data lives on this server, and all we can get from here is a valid access token. The user data lives on a resource server, and to talk to this server, we need access tokens to get past the gate. By keeping things separate, we add these additional layers of security. The second important thing here is that to participate in the OAuth flow, prior to any user involvement, we need to let the Treehouse server know about our application. We do this by registering our application with the server, and in return, the Treehouse server gives us two pieces of information: a client ID and a client secret. The client ID is public information that identifies our application, sort of like a username, while the client secret, like a password, authenticates our application before we can make that initial authorization request. Always guard your client secret because with a client ID and secret, anyone can pretend to be your application. Okay, so that was a high-level overview of the OAuth 2 flow. In the next video, let's break it down and take a look at some of the details.